everyone, this is Isha from the Manchester College of Engineering, pursuing my studies in computer science engineering. Today's topic is vector line integration. So let's talk about vector line integration. Vector line integration is a powerful mathematical tool used to study various physical phenomena. In this presentation, we will explore its concepts, types, and applications. You can see an example of vector line integration here. So, so calculation of line integrals. So in calculation of line integrals, we have three types: dot product, cross product, and parametric curves. So firstly, dot product, which is denoted in the form of dot, single dot. So the dot product of a vector field f of x comma y and differential vectors is used to calculate line integrals in of scalar function. So it is basically used, the dot product is basically used to uh, find the scalar functions of a line integral. Here we have an example of a vector b, which is equals to a magnitude of a vector and b vector cos theta, which is the main formula. So a vector dot b vector, which is equals to 0. The two vectors are perpendicular to each other. They are perpendicular to each other, and if and only if their dot product is equal to 0. Ne- Now, cross product. The cross product of f of x comma y and ds is used to calculate the integral of vector function. So the dot product. So dot product is denoted in the form of x. So a x b, which is equal to magnitude of a, magnitude of b, sine theta, and n vector. Area of parallelogram, magnitude, and unit vector are basically uses this cross product. Cross product is used mainly in 2D. This is called as two-dimensional. Now, parametric curves. Parametric equations are defined as x is equals to x to the x of t and y of t. The integral is then calculated as integral f of xt and y of t and d into uh, dx of t by dt and dy of t by dt to, into dt. So in this way, parametric equations are solved. Parametric curves are formed. You can see an example here. This is in two dimension, 2D. Now, types of line integrals. First, conservative line integrals. Second, gradient field. And third one is conservative line integrals. Firstly, conservative line integrals. A line integral integration of f of x comma y ds over a path c is said to be conservative. Conservative if the integral is path independent. Gradient field. If f of x comma y is gradient of the scalar function f of x comma y, the line integration of f of x comma y ds is said to be the path independent and equal to fb fb minus fa, where a and b are endpoints of c. Now, third, non-conservative line integrals. If f of x comma y is not the gradient of a scalar function, integration of f of x comma y ds is path dependent. Now, applications of line integrals. So, the applications of line integrals consist of three types: electrical field, magnetic field, and fluid mechanisms. In electrical field, flux is calculated as a surface integral of the electric field E over a closed surface. So this is a closed surface S with an enclosed charge Q. So this is an example of electrical field. So magnetic field. The magnetic field around a conductor is calculated as a line integral of the current density around the conductor multiplied by 2 pi r, where r is the distance and the point of interest from the conductor. This is called as magnetic field. So mechanics. In fluid mechanics, line integrals are used to calculate work done by force when a fluid passes through a pipe or a duct. Now, challenges to integration. There are three challenges. Uh, Now I'm describing the three challenges of line integration. So closed loops, non-continuous functions, and path dependence. Closed loop. Line integrals are not defined of for curves that encloses a region. Instead, Green's Green's theorem is used to calculate the integral over the enclosed region. So this closed loop can be studied in Green's theorem. Non-continuous functions. Line integrals of non-continuous functions do not exist, and these days, continuous functions need to be evaluated stepwise. Path dependence. Non-conservative line integrals are path dependent, and different curves may yield different results. So this is mainly on path. This path dependent. Now, so the conclusion and the future direction where this line integration uh, or the integration goes is its application. Mainly, we'll look into the applications. Line integrals play an essential role in the study of many physical concepts such as electric and magnetic fields and fluid mechanisms. So, potential. Line integrals have many practical applications in fields like engineering, physics, economics, future development. It will keep making them more versatile and useful. So, so this is the conclusion. So line integrals are everywhere, which is used in every field. It is used in economics, it's used in geometry, it is used in biology, it's used everywhere. So this was my topic of today. Thank you very much. Guys, do subscribe, do like, and do share, do comment. Thank you.